Welcome back to a new session of MOOC on Information Security. Substitution Techniques. This part presents an overview of some more substitution ciphers such as polyalphabetic ciphers, Playfair cipher and Hill cipher. These ciphers are the popular types among the traditional substitution ciphers. With this module, learners will get a consummate knowledge about the listed ciphers and a glimpse of awareness to learn much complex modern ciphers. Polyalphabetic cipher. In contrast to the monoalphabetic cipher discussed earlier, here each letter or character of the plain text is replaced with different letters. Relationship between a letter in plain text with a symbol in ciphertext is one-to-many. Auto-key cipher, Vigenère cipher, Hill cipher and Playfair are the most common algorithms for polyalphabetic cipher. A reference to auto-key cipher has been made in the previous session. Hill cipher and Playfair cipher are the concern of this session. Playfair. One among the fascinating polyalphabetic ciphers which has been elegantly used in the First World War by the Great British Army. Here, the ciphertext or secret key is made of 25 alphabet symbols randomly arranged in a 5 by 5 square. Of the 26 alphabets, characters I and J are put inside a single cell. Random filling of alphabets in the square matrix can create many different secret keys. There are two ways used to fill out the 5 by 5 matrix. Some encoders use a keyword to get started filling the matrix out. At the outset, they select a word that often never repeats characters. For example, algorithms, blueprints, magnitude, etc. Here we may use background as a case in point. So the steps are: first of all, fill out the matrix with the selected keyword. Here we are filling out the matrix cells with the spellings of the word background. Rest of the cells shall be filled out with remaining letters of the English language. As said, I and J are always placed inside a single cell. Before beginning the actual encryption, a few preliminary adjustments of the plain text or PT is needed, and they are as follows. Initially, we need to make letter pairs from the plain text or PT. If the two letters in a pair are same, then a mock or bogus letter is needed to be inserted in between them as shown in the example below. If our plain text is balloon, then a bogus letter X or any other letter should be inserted in between L and L as well as O and O. That is, balloon becomes BALXLOXON. Now, the pairs are BA, LX, LO, XO and N. If the last letter is single, it shall also be made into a pair by adding a bogus letter once again. That is, after inserting bogus letters, the number of characters shall be even. Eventually, we have the following pairs ready for our encoding process: BA, LX, LO, XO and NX. The final steps of Playfair involves the following procedures. Take each pair separately and follow the steps ahead. In the first step, if the letters in a pair belong to the same row of the matrix, the corresponding cipher code for each letter would be the next letter to the right of each one in the same row. If the plain text letter is the last letter in the row, the ciphertext should be the first or the beginning letter in the same row. If the letters in a pair are placed in the same column of the 5 by 5 matrix, the equivalent ciphertext would be the letter just beneath to the plain text in the same column. If the plain text letter is the last letter in the column, the ciphertext would be the first or the beginning letter in the same column. If the two characters in a plain text pair are located other than the same row or same column, the corresponding ciphertext letter would be a letter that is in its own row but in the same column of the other letter of the same plain text pair. Playfair meets the criteria for a polyalphabetic cipher. We can make use of the above illustration of balloon to make out the algorithm easily. BA becomes AC, LX becomes QI or QJ as I and J always belong to same cell, LO becomes SL, XO becomes RQ and so on. Hill cipher. The Hill cipher is a polyalphabetic substitution cipher based on linear algebra. It was invented by Lester S. Hill in the year 1929. In simple words, it is a cryptography algorithm used to encrypt and decrypt data for the purpose of data security. The algorithm uses matrix calculations used in linear algebra. It is easier to understand if we have a basic knowledge of matrix multiplication, modulo calculation, matrix arithmetic modulo 26, square matrix, determinant and the multiplicative inverse calculation of matrices. In a Hill cipher, the key is a square matrix of size m by m in which m is the size of the block. That is, m equals the number of letters in each block of plain text. For example, if the plain text is meet me at downtown, and since Hill cipher is a block cipher, we need to convert it into a square matrix with different fixed size blocks illustrated below. The matrix will be meet, me at, down, time. Here the size of the block is equal to 4, that is the number of letters in a row, and hence the key should be a 4 by 4 matrix. In Hill cipher algorithm, every letter from A to Z is represented by number moduli 26. Usually, the symbol substitution scheme is used where A equal to 0, B equal to 1, C equal to 2, etc., Z equal to 25 in order to use m by m key matrix. This can be expressed as C equal to E of Kp, which is equal to P into K mod 26. P equal to D of Kc, which is equal to C into K raised to minus 1 mod 26, which is equal to P into K raised to minus 1 mod 26. With the given example, we can use Hill cipher as follows. The first block in the plain text matrix is meet, and its corresponding code in above mentioned symbol substitution scheme is m becomes 12, E 4, next E also 4 and T 19, which is P1, P2, P3 and P4. Therefore, C1, C2, C3, C4 equal to P1, P2, P3, P4 multiplied by the matrix of K, that is K11, K12, K13, K14 up to K41, K42, K43, K44 mod 26. C1 equal to P1 K11 plus P2 K12 plus P3 K13 plus P4 K14 mod 26. C2 will be P1 K21 plus P2 K22 plus P3 K23 plus P4 K24 mod 26. C3 will be equal to P1 K31 plus P2 K32 plus P3 K33 plus P4 K34 mod 26. And the last C4 will be P1 K41 plus P2 K42 plus P3 K43 plus P4 K44 mod 26. These steps will follow for the remaining blocks as well. A thing to be noted is that the key matrix in the Hill cipher needs to have a multiplicative inverse. Multiplicative inverse can be easily found using extended Euclid algorithm. So, in this module, we have elegantly discussed about substitution ciphers like Playfair cipher and Hill cipher that were once popularly used in the history. These ciphers belong to block cipher, one among the two categories of substitution ciphers. The advantage of learning these ciphers are much imperative to get a conspicuous knowledge of somewhat complex modern ciphers, which are a good mix of both mathematics and its allied subjects. Hope this session was useful for you. See you next time. Bye.